Okay, so this section is chapter 2, section 3, and we're going to talk about polynomial and synthetic division. So when we do long division, here are some helpful suggestions as you're working through. Remember to arrange the terms of both the dividend and divisor in descending powers of the variable. Remember to divide the first term in the dividend by the first term in the divisor. The result is the first term of the quotient. Third thing you want to do is multiply every term in the divisor by the first term in the quotient. Write the resulting product beneath the dividend with like terms line up. Subtract the product from the dividend. Bring down the next term in the original dividend and write it next to the remainder to form a new dividend. And then use this new expression as a dividend and repeat this process until the remainder can no longer be divided. This will occur when the degree of the remainder is less than the degree of the divisor. Okay, so let's take a look at. Okay, so here's our first example. We're dividing this by 3x minus 2. So 3x minus 2 goes out. And then I get 9x squared plus 6x plus 5. Okay. What I want to do is I want to look at these first two terms. The term that's out here and the term that's in here. Okay, 3x times 3x is going to give me 9x squared. Okay, remember that you have to also distribute it to the second term and then line it up wherever it goes. So you have 3x times negative 2 is negative 6x. The next thing I want to do is I want to take the differences. So that means that 9x squared minus 9x squared is 0. And then my next term I have minus a negative becomes plus a positive, so that's 12x. Bring down your next term. And we're going to repeat the process over again. So we want to look at the first term out here, 3x times what is 12x? Okay, good. So that's plus 4x. Alright, so moving on, 12x is going to be the result of 3x times 4. Okay, so then I'm going to line that up, distribute it. So 4 times 3x is 12x, and then 4 times negative 2 is negative 8. Remember, we're taking the difference of these terms. So 12x minus 12x is 0, and 5. Remember, you have minus and negative, so that's plus positive. And then I get 8 plus 5 is 13. That's my remainder. So when I have this, this is my actual solution with a remainder of 13, and this is how we're going to express it. 3x plus 4 plus whatever our remainder is. 13 over what we were dividing by, 3x minus 2. Alright, so let's make sure we understand the concept. So let's divide x cubed plus 3x minus 2 by x squared plus 5x minus 3. Remember when I showed you the steps, you always want to write them in descending power, and if anything's missing, if you notice over here x squared is missing, you have to represent it with a place value. So I'm going to write 0x squared. So I'm dividing x cubed plus 0x squared plus 3x minus 2, and we're dividing this by x squared plus 5x minus 3. Okay, so we're going to repeat the process that we did in the previous example. Remember, we always want to look at the first terms. X squared times what is x cubed? Well, that's x. So we're going to just line that up over wherever that x is. Then we're going to distribute that x to all three terms in here. So x times x squared is x cubed, and you line that up wherever that is down here. And then you have x times 5x is 5x squared. So plus 5x squared goes here. And then we have negative 3 times x is negative 3x, and that goes here. Now I want to take the difference. So it's minus, minus, and minus. X cubed minus x cubed is 0. 0 minus 5x squared is minus 5x squared. And then here I get minus and negative is plus positive, so I get 6x. And now I'm going to look at these terms again. X squared and negative 5x squared. What do I need to multiply x squared by in order to get negative 5x squared? Negative 5. So we're going to put the negative 5 here, we're going to distribute it. Because the way this one ends up, I want to bring down this negative 2. Okay? So I'm going to go ahead and distribute because there's 3 terms here. I need 3 terms here. Okay? I need that to be consistent. So negative 5, distribute that to all 3 terms, and I'm going to line them up here. Negative 5 times x squared is negative 5x squared. Negative 5 times 5x is negative 25x. And negative 5 times negative 3 is positive 15. Now I'm going to take the difference. So minus, minus, minus. Okay, here I get 0. Here I get 31x. And here I get negative 17. So I'm going to express it just like I did before. My answer is going to be x minus 5 plus my remainder. So plus 31x minus 17 over, and remember we divided by x squared plus 5x minus 3. And that's how I set that up. So the division algorithm, if the remainder is 0, then we say the divisor divides evenly into the dividend, and the divisor and the quotient are factors. And we're going to come back to this concept in just a moment, but let's take one more example with synthetic division. Okay, so let's go ahead and fill in what's missing. I'm missing x. Does everyone see that? So I need to put in that place value, so it's going to be plus 0x. And then we're going to repeat the process we were doing before. 2x times what is 6x cubed? Okay, so we're going to line that up where that goes. That goes here. Distribute it. 3x squared times 2x is 6x cubed. And then 3x squared times negative 5 is negative 15x squared. Now we're going to take the difference here. When I subtract these, I get 0. When I subtract these, I get 11x squared. Bring down your next term. Okay, 2x times what is 11x squared? 5.5. I'm going to write fractions because 11 over 2 times 2 reduces to 11. So that's going to be plus 11 over 2x. Distribute that, and you're going to get 11x squared, and then that looks like negative 55 over 2x. Take the difference. Here you're going to reduce to 0, and then here this is going to become positive 55 over 2x. Okay, so now we want to go back to the concept over here. 55 over 2x times what? I'm sorry, I said that backwards. 2x times what is 55 over 2x? 55 over 4. And don't forget to bring down that 7, so let's bring that down. Plus 7, and then here I get 55 over 4. So when I distribute 55 over 4 times 2, that's going to be 55 over 2. Right? Everyone agree? And then we're subtracting 55 over 4 times negative 5 is negative, let's multiply that really quickly. Okay, and we get 275. Okay, so 275 over 4. Okay, and remember we're subtracting a negative, so that means we're going to be adding that difference right there. So let's move this over. This reduces. Here I need, and that's 2. That's 2. 275 over 4, I need a common denominator, so I'm going to do 7 times 4 over 4, so that's 28 over 4. And I'm going to do 28 plus 275 is 303 over 4. Okay, and now I'm going to express my solution the way I would, like the previous examples, this, and express with this as a remainder. Okay, and be careful when you do that. It should look like this. Because it's a fraction, I have 3x squared plus 11 over 2x plus 55 over 4 plus our remainder, which is 303 over 4 over what we were dividing by, which is 2x minus 5. But I don't express it like that. I have to do state change, flip, and simplify this. So let's do that. So I get 303 over 4 times 1 over 2x minus 5. So this is where the difference is when we have a fraction as a remainder. You wouldn't express a decimal in the numerator either. That would be incorrect. So you would have to simplify that. So here when I finish simplifying this, my numerator is 303. Distribute the 4 to 2x minus 5 and you get 8x minus 20. That's what should be in here. Alright, so let's talk about synthetic division. When we're doing synthetic division, it's easier than long division. We're going to just express what we're dividing by and the coefficients. Okay? So we want to begin by arranging the polynomial in descending powers with a 0 coefficient for any missing terms. We also did that for long division, so that's something that we're also incorporating here. Then we're going to be given the divisor x minus c. We're going to just write c to the left of the coefficients and the coefficients to the right of the constant. If I have x plus c, I'm going to write minus c to the left of those coefficients. I'll show you what I mean in just a moment. I'm going to follow these steps, and if I were you, I'd write these down and then just watch me as I do the next example. So here's our first example, and this is what I was talking about. Here I have x plus c. So I have to take the opposite, which is negative 2. So I'm going to put negative 2 to the left of my coefficients. I only want coefficients. I do not want the variables, so leave those guys out. So in descending powers or degrees, because x squared is missing, I'm going to put in a 0 as a placeholder. So 5 is first, then 0, then 6, then 8. Okay, I'm going to bring the first one down, and I'm going to multiply these two terms together. Negative 2 times 5 is, then I'm going to add these two together, and I get, and then I'm going to repeat the process. So now I want to multiply these two together, the negative 10 and the negative 2. What do I get? Okay, I get positive 20, and then 20 plus 6, because that's my next step. Okay, 26. And then I want to multiply these two together, 26 times 2. 26 times 2, 52. Alright, so 26 times negative 2 is negative 52. And now I'm going to take the difference, negative 52 minus 8, negative 44. Okay, and that's my remainder, so I'm going to re-express it, depressing it a degree. So if I started with the third power, I'm going to go down 1, so my answer is going to be expressed starting with the second power. So that's going to be 5x squared minus 10x plus 26 with our remainder. Remember, because it's minus, I can write minus. And our remainder always goes over what we were dividing by, and we were dividing by x plus 2. So we're going to write x plus 2 in the denominator here. And I don't have to simplify that fraction. That fraction's already simplified, not like our previous example. Let's look quickly at another example to make sure that you understand the concept. Remember, when I'm dividing by some number, I want the constant by itself to the right of to the left of the coefficients. Then I'm going to take all the coefficients here, no variables and constants, and put them to the right. So that's going to be 3, negative 5, 7, negative 8. Bring down your first term, multiply these two, okay, and you get 4 times 3 is 12. So get rid of that so you don't get confused on that. So that's going to be 12. Negative 5 plus 12 is 7 times 4 is 28 plus 7 is, and 35 times 4 is positive. Okay, and then my remainder is 132. Okay, and we're going to depress it because we started to the third power. Our answer is going to be 3x squared plus 7x plus 35 over our remainder over what we were dividing by. And that is our answer. And now we're getting to the concept of the remainder theorem. But before getting to the concept of remainder theorem, let me just go over here and I want to recap something with you guys. Let's say I have f of x equals x plus 2. And I tell you to find f of 1. What would you do? Plug in the 1 for x. So we would say 1 plus 2 and we get 3. So our answer for f of 1, our solution, is this. Everyone agree? What the remainder theorem here is saying is if the polynomial f of x is divided by x minus c, then the remainder is the solution. Okay? So if you are given the function and you want to find f of 2, then the remainder of the function is the answer. So 5 is f of 2. So if I were to plug in 2 in here, here, and here, I would end up with 5, and that's what this is saying. Okay, let me show you an example. Alright, so here's our example. We're going to use synthetic division and the remainder theorem to find the indicated function value. So we begin this by using synthetic division. So put the 3 there, negative 5. I need a 0 for x to the first power, right, because that's missing, and then 1. And I'm going to begin the process. Bring the first term down, multiply that to what's in the box. 3 times 2 is, add negative 5 plus 6, 2 times 1, add 0 plus 2, 2 times 2, add this and you get 5. So this means that f of 2 equals 5. And I'm just going to do a little side check here. Let's actually find f of 2 the long way. Let's find it the way we knew from before. So 3, 2 cubed minus 5 times 2 squared plus 1. 3 cubed, we got 8 times 3 is 24. 2 squared is 4 times 5 is 20 plus 1. 24 minus 20 is 4 plus 1 is 5. So that's me checking my work to make sure that that is in fact my answer. And that's where that remainder theorem is coming from. It's the same thing as doing this. So now we're going to use the factor theorem. So just like the remainder theorem, we end up with the remainder. What the factor theorem says is if our remainder is 0, then what I was dividing by is a factor. Okay? So let's take a look at this. The factor theorem, let f of x be a polynomial. So think back to section 2.2 when we have those polynomials. We were looking for the end behavior. We were looking for the zeros. We were looking for max turning points, the y-intercepts. This is going to play a role in sections to come. So what I'm going to say is really important. This is going to help us in the future, so we need to understand this concept. Okay? When you are given a solution, use synthetic division to reduce the degree of the initial polynomial, then factor to find the remaining roots. Okay, so let's say I have some polynomial. F of x equals, and I'm making this up. Alright, so let's make one up. Let's say I have f of x equals 2x squared plus 10x plus 12. And let's say I tell you that it has a 0 at negative 3. So let's check it. Let's use synthetic division. If my remainder is 0, then it is a solution. So 2, 10, 12. Bring down the 2. Negative 3 times 2. 10 plus negative 6. That's 4. Negative 3 times 4. When I add them, what do I get? 0. Let's depress it, because remember, we start to the second power, so that means my answer is going to go to the first power, so that's 2x plus 4. This is also going to be a 0, because now this tells me where, because this is quadratic, that means it's a parabola. This tells me where the parabola is crossing the x-axis. So it's what Cedric was pointing out. If it's a 0, does that mean it's an x-intercept? The answer to that is yes. Okay, so here I have two x-intercepts. This one at x equals negative 3, the one I told you from the beginning, and then I have this one, x equals negative 2. So if I wanted to, I could actually graph that parabola at negative 3, negative 2, and create a parabola there. Okay, I estimated where it is. I don't really know that it's there, but I just wanted to make the point that that polynomial is crossing the x-axis at those points. And that's what we're looking for. That's what the factor theorem is going to help us do. Let's take a look at this example. It says solve the equation given that 2 is a 0. So it's telling me it's a 0. I want to solve it. Okay, a quick side note, and I said, please write this down so that it helps you. When you're solving an equation, that means you're finding all solutions for x. You're looking for all the x-intercepts possible. You're looking for all the zeros. You're looking for where does this polynomial cross the x-axis. I want all of them. So when you see those instructions, you're not just finding one and then stopping. No, you're finding all the x-intercepts. So they give me 2, so I'm going to start with that one. And I'm going to set up my synthetic division. So I have 2. Alright, so now we're setting up those coefficients from the given to the right of the 0, which was 1. X squared is missing, so I'm going to put in a 0, negative 7, and 6. So this one is representing x cubed, x squared, x to the first power, and our constant. Okay? Bring down your first term. 2 times 1 is 0 plus 2 is 2 times 2 is negative 7 plus 4 is negative 3 times 2 is. Add them and you get. Okay, if I did not get a 0 there, because the instructions told me that 2 is a 0, remember the factor theorem says that our remainder must be 0. If I didn't get a 0 and they told me it was a 0, I did something wrong. Go back and check your work. Okay, now we want to depress it. We started with a cubed. Now we move on to a quadratic. So our answer is going to be here x squared, because 1 can be there or not there. You can express it there if you want to. Plus 2x minus 3 equals 0. Okay, remember, we're not stopping here. That's not the answer. The instruction said to solve the equation. That means find those x-intercepts. From here you have some options. Because it's quadratic, you have 3 options. Complete the square if you cannot factor it. If you can factor it, good, factor it. Use the quadratic formula, that would be option 2. Or 3, continue with synthetic division. If you're continuing with synthetic division, you kind of have to pick numbers and see if it works. And we'll talk more about that in a future section. But because this is quadratic, I always think it's easier to start by asking yourself, is this factorable? If not, either complete the square or use the quadratic formula. Okay, is this factorable is my question to you guys. Yes. Okay, what are my factors? Okay, good. 3 and negative 2. And remember, we're looking for zeros. We're looking for x-intercepts. We're looking for solutions. This tells me where the polynomial... Oh, thank you guys. Everyone makes mistakes. Yes, thank you. Okay. 1. Okay, this tells me where this polynomial function is going to cross the x-axis. So here I'm going to get x equals negative 3, and here I get x equals 1. So my solutions, I'm going to list them out. Remember, they gave me one of my zeros. Negative 3, 1, and 2. So I have 3 x-intercepts for the given, and that's my solution set. Remember, when it says solve the equation, I want all x-intercepts. Do not stop here. Alright, so here's our last example. It wants us to, example number 8 says, verify the given factors of f of x, find the remaining factors, and use your results to write the complete factorization. Then we're going to create a solution set for the zeros. Okay, because it says verify, it's not for sure that this is a 0 and or that this is a 0. It could be that they both work, or it could be that just one works and the other one doesn't. It could be that this one works, this one doesn't, this one works, this one doesn't. I don't know until I check it. So what I'm going to do is I'm going to set this up with synthetic division, and I'm going to pick this one. If it works, then we can continue with this one. If it doesn't work, then because we're starting at cubic, I'm going to get a quadratic. I would go ahead and factor it. Okay, so let's start with x plus 2. And I prefer using synthetic division because I think it's easier. So I'm going to start with -2, because remember, opposite sign is going to go to the left of other coefficients. 2, 1, -5, 2. Bring down your first term. -2 times 2. 1 plus -4. -2 times -3. -5 plus 6. -2 times 1. Add them, you get. Is it a factor? Yes, -2 is an x-intercept. So let's go ahead and depress it. So I get 2x squared minus 3x plus 1 equals 0. Okay, because we're quadratic right now, we have options. Complete the square or use quadratic formula. However, we still have a possible factor hanging out from the instructions at x minus 1. So I'm going to go ahead and test it, see if it's 0 or not. So I'm going to set up the same process for the 1 and write the coefficients for this polynomial to the right of this. So now I'm testing 1. I don't know whether it's 0 or not. I'm checking it. If it works, then I'm good. If it doesn't, I'm going to need to come back here, use quadratic formula, or complete the square. Your choice. Okay? So now I'm going to set up my coefficients to -3, 1. Bring down the 2. 2 times 1. -3 plus 2. 1 times -1. 1 plus -1. Did it work? Yeah, it worked. So it turned out for this example that they were both factors. Is that always going to be the case? No. Okay, so remember, when you get it quadratic, keep it easy. Just use quadratic formula, complete the square if you cannot factor. If you can factor, then it's super easy. You're good to go. You have your zeros right in front of you. Okay, so our answer here is going to be 2x minus 1 equals 0. What's my last 0, guys? Good, x equals 1 over 2. Now I want to list them out. So my solution set is -2, 1 over 2, and 1. That answered, we verified using synthetic division. We found the remaining factors, 1.5, and then I created my list. My list is D. Okay? And then part C, we forgot to do that part. Complete factorization is going to be the following. Our factors are x plus 2, x minus 1, and our last one was from right here, the 2x minus 1. That's the complete factorization.